Here's example 9 with integration by substitution. So examples like this are fairly common also. You know, we just, same kind of thing, substitution, but we have this arbitrary function f. We don't really know anything about it except that f is continuous and we know this integral here. So find the integral from 2 to 3 of f of 2x dx if f is continuous, and the integral from 4 to 6 of f of x dx is 7. Okay? So this is actually a little simpler than it sounds. So we're told that f is continuous, and you know, that might be kind of worrisome, but really that just tells us that these integrals exist. Okay, so if f is continuous, that just guarantees that this integral and this integral both exist. Of course, we know this one exists because it's 7, but you know, we know that this one exists because f is continuous. So we don't really have to worry about anything. So that's all this continuity really means. It's just that this integral exists and we're okay. So the only real important piece of info that we have to worry about then is this. Okay, so that's the one that we're really going to use. Okay, so let's go ahead and start evaluating stuff. So we want to figure out the integral from 2 to 3 of f of 2x dx. Okay? So what we're talking about integration by substitution, and the only thing that we know is this, so let's go ahead and do a substitution. Let's let u be the inside guy. Okay, in other words, you know, I know what f of just a variable is. If I integrate that from 4 to 6, I know what that value is if f is just f of a variable. But here I have f of 2x, so let me take 2x and rewrite that as u. Okay, so two different ways to think about that. Let u be the inside guy, or just take this 2x, rewrite it as a single variable with no 2, because that's what I know something about. So if du is, or sorry, if u is 2x, then du is 2 dx, right? But I don't have 2 dx, so let me zoom in a little bit. I don't have 2 dx, I just have dx. So let me stick a 2 in here. So what did I just do? I just multiplied everything by 2. So let me divide everything by 2 to make that okay. Okay. So now the integral becomes the integral, so 1/2 f of u, right? So 2x is u. So 1/2 f of u, and then 2 dx, so this 2x is u, and then 2 dx is du. Okay. And we still have this 1/2 out here. Now what about the limits? So be careful, don't say 2 and 3, that'd be wrong, right? Why is that wrong? Because 2 and 3, those are limits for x. X goes from 2 to 3. X goes from 2 to 3. Now when we have blah 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 du, that's integration with respect to u. So u has to go from something to something else that might not necessarily be 2 and 3. So what do? We set up our little chart, right? So we'll come over here, set up our chart. So x and u. So x goes from 2 to 3. When x is 2, what's u? U is 2 times 2, which is 4. When x is 3, what's u? 2 times 3, which is 6. Well, that's actually really good. You know, why is that really good? So now what do we have? So this integral grows from 4 to 6. Okay, that's what we just found out over here. Okay, so we have the substitution u equals 2x, so when x is 2, okay, when x is 2, u is 4. When x is 3, u is 6, is what we just found out with this chart. So now let's go ahead and continue with this. So let's zoom back out just a bit. So now this equals, so we'll pull the 1/2 out, it's just a constant multiple, so we can pull those out of integrals. So this is the integral from 4 to 6 of f of u du. Okay. Now that's great. Why is that great? Well, we know what this is, right? Integral from 4 to 6 of f of x dx is 7, so it's just the same thing. So if you're wondering, well, hey, this is x and this is u, that actually doesn't matter, right? So remember, when you integrate, when you have definite integrals, this variable is what's called a dummy variable, so it doesn't matter what you call this. Okay, so the point is, integral from 4 to 6 of f of a thing, d thing, equals 7. Okay, in this case, that thing is x. So f of blah d blah, integrate from 4 to 6, you get 7. Okay, so integral from 4 to 6 of f of x dx is 7. Integral from 4 to 6 of f of u du is 7. So this is 1/2 times 7, which is just 7/2. Okay. So, you know, really straightforward, not too bad at all. Just, you know, same kind of thing, just a substitution, but just with an arbitrary function f. We don't know anything about f except that it's continuous, and we have this integral here. And again, you know, what's going on here? Integral from 4 to 6 of f of blah d blah equals 7. Integral from 4 to 6 of f of blah d blah equals 7. Then we have the 1/2 out here. Okay. So again, so just be very careful about that. So a main point here is that it doesn't matter what this variable is. It's called a dummy variable because it just doesn't matter what it is. Okay, f of a variable and then d variable, whether it's u or whether it's x. Okay, if you have that, if you integrate from 4 to 6, you'll get 7 for this particular f that we were given for this problem here. So anyway, that's example 9 with integration by substitution, and the answer again was 7/2.